In this video, I'm going to talk about using pivoting to perform Gauss-Jordan elimination on matrices. Pivoting is a specific procedure in transforming matrices. If you need clarification on pivoting, please click on the link at the top right corner. The goal of Gauss-Jordan elimination is to obtain the reduced row echelon form, or sometimes in short, the row-reduced form of a matrix. It is important to notice that every matrix has exactly one corresponding reduced row echelon form. A matrix has to satisfy 4 criteria in order to be classified as a reduced row echelon form. First, if there are rows of all zeros, they must be all packed together at the bottom of the matrix, like this. If there are no rows of all zeros, then this criterion can be skipped. Second, in every row, the leading entry must be a 1. By a leading entry, we mean that it is the first non-zero entry in each row. So, when we say that every row has a leading 1, we mean that when we walk along a row, the first time you hit a non-zero entry, this entry must be a 1. Third, all the leading ones are arranged in a downward and rightward staircase form, like this. We can see that all the ones are arranged in a downward and rightward direction, like a staircase. Lastly, in a column that contains a leading 1, all other entries in that column must be zeros, like this. As for the rest of the entries, they can be completely arbitrary. We don't have any control over them. They can be 0 or 1 or any other numbers. How can we transform an arbitrary matrix into its reduced row echelon form? The method is called Gauss-Jordan elimination. And we are going to illustrate that technique with the following example. Let's look at this 3 by 4 matrix with 3 rows and 4 columns. Remember that we want to create leading ones in the position as top left as possible, and pivoting is well suited for this task. So the first thing we will do is to pivot at this non-zero entry 2. And we will do this by multiplying the reciprocal of the pivot entry, which is 1/2, to the first row, our pivot row. 1/2 times R1 will give us 1, 3/2, -1/2, and 2. There is no change in the other 2 rows, and we are just copying them one by one. The next step of pivoting is to ensure that all other entries in this pivot column are zeros. Because we need to change this -4 in the second row, I'm going to put down R2 at the beginning. The pivot row that we are using is R1. And in order to change -4 into a 0, we are going to do +4. We also need to change this 3 in the third row, so I'm going to put down R3. The pivot row once again is the first row, and we should put -3 in the middle because we need to turn the +3 into a 0. The auxiliary row 4 times of R1 is given by 4, 6, -2, and 8 by multiplying 4 to every entries in the R1. Similarly, -3 times every single entry in R1 will give us -3, -9/2, +3/2, and -6. This auxiliary row is going to be added to R2, so we will get 4 plus -4, which is 0, 6 plus -6 is 0, and the other 2 entries are 1, and 9. This auxiliary row is going to be added to all 3, so we are going to get -3 plus 3, which is 0. -9/2 plus 4 is -1/2, and the rest of the entries are -3/2 and -4. The first row is not changed, so we are just going to copy all the entries. This finishes the first pivoting. Next, we would like to make sure that this entry is a leading one. However, we cannot pivot at this entry because this is a 0. What can we do? Well, the next trick is to switch these two rows so that this non-zero entry is going to be in this position and we can pivot at that. In other words, we are going to do R2 interchanging with R3. We're going to use this double-sided arrow to indicate interchange. The first row is not changed, so we're just going to copy it. And then the second row goes to the new third row. And the third row goes to the new second row. Some of you may ask, could we try to interchange the first row and the second row so that this non-zero entry will go here instead? The answer is no, because if we try to switch the first and the second row, then this one will go here and this 0 will go top. This violates the condition that we would like our leading ones to be in the as top left position as possible. After switching these two rows, we are going to pivot at this non-zero entry by multiplying the reciprocal to this row, which means -2 times R2. So the second row becomes 0, +1, +3, and +8. The other two rows are not changed, so we are going to copy them. The next step of pivoting is to ensure that all other entries of this pivot column are zeros. Therefore, we need to change R1. We are using the second row as the pivot row, so I'm going to put down R2 here, and I'm going to put down -3/2 so that we can turn +3/2 into a 0. The auxiliary row of -3/2 times R2 is given by 0, -3/2, -9/2, and -12. When this is added to R1, we will get 1, 0, -5, and -10. The other two rows are not changed, so we just need to copy them. This completes another pivoting. Notice that we have already created two leading ones with entries above and below them being 0. Next, we need to create a leading one here by doing another pivoting. We are going to copy this matrix over to the next page. When we pivot at this entry, we need to multiply the reciprocal of this entry to this row. But the reciprocal of 1 is just 1, and there's no change to this row. So all we need to do is to ensure that these two entries are changed to 0. -5 is in R1, and the pivot row is R3. We need to do +5 in the middle so that this -5 is turned into 0. As for this 3, it lies in R2, the pivot row is R3, and we should do -3 to turn it into 0. The auxiliary row 5 times of R3 is given by 0, 0, 5, and 45. And the auxiliary row -3 times R3 is given by 0, 0, -3, and -27. When we add this to R1, we will get 1, 0, 0, and 35. When we add this to R2, we will get 0, 1, 0, and -19. Finally, the last row should be copied. Notice that we now get leading ones in every single row. They are in downward staircase form, and above and below the leading ones, they are all zeros. Therefore, we are done with this Gauss-Jordan elimination and obtain the reduced row echelon form. If you like this video, please subscribe to our channel and we will learn more fun math together. Thank you for watching.